This is the first question, okay, of the next video. So the question is, in the adjoining figure, the figure what they gave you, okay, where AB is parallel to DC, okay, is there? Okay. If AC and PQ intersect at the point O, is they are intersecting? You have to prove this one. So they have given you AB and AC are, AB and DC are parallel and they intersect at O and nothing else they gave you and they told you to prove. Okay, let me see what we can do. So we have to prove this one. Okay, so first let me break this one, what we can do from here. Solution. Okay, so what you have to prove, OA into CQ equal to OC into AP. Okay, so this one we have to prove. Okay, for that what we have to do, let me see what we can do. Now let me arrange them. First you see OA and CQ. OA and CQ, where is OA? Sir, OA and CQ. CQ, sir, no sir, they are not lying in the same thing. Okay, so OA and CQ are not together in the diagram because we need to first we have to see in which triangle they are coming actually. So then we will prove that triangle is similar, and by using some property we will say this one equal to this one. So now you have to see which triangle you have to prove similar. For that I am just trying to crack this one. So OA and CQ, no, they are not lying in the same triangle. Okay, next you see OA is there. So if OA is there, it should be OP or AP. Then I can have this triangle. This side any OA, OP and AP is there. Sir, AP is there. So means OA and AP is together. Okay, can we write this one like this? OA by AP. Sir, you can write. So we are left with, sir, OC and CQ. Let me see OC and CQ coming in same triangle. OC and CQ. Yes, sir, they are coming in same triangle. Okay, now we can write like this also, na? So OC by CQ. Can we write? Yes, sir. Can we write CQ by OP? No. Why? Because if you write like this, okay, say for example, if I am writing like this, OA by AP equal to CQ by OC. Is it right? No, sir, it's not right. Why? They are in the same triangle only now. But the thing is that when you multiply, you should get back the same thing. So when I'm OA into CQ, no, OA into OC, I'm getting, no, sir. But here if you say OA into CQ, yes, sir, I'm getting. AP into OC, yes, I'm getting. But if I'm arranging like this, I'm not going to get this one back. So this is the wrong arrangement. Instead, if it is the same triangle, right only, but the arrangement what you did is wrong. Okay, so we'll omit this one. We'll not do like this. Okay, we have to consider that one also. Well, rearranging them. Okay, so this is the wrong arrangement. Understood? So arrangement is also important. This is the right arrangement. So we'll ignore this one. Why we have ignored? Why it's wrong? Understood. So after arranging, you need to see whether you're getting back the question or not. OA into CQ, yes, sir, together. AP into OC, yes, they are together. So this is the right arrangement. Okay. So after this, we got the triangle OAP. Which one? So from here we came to know the triangle is APO, and from here the triangle is COQ or CQO, anything. Okay. So we understood we have to take these triangles, we have to prove them similar, then we'll get this answer. Okay, sir. Now, so how to prove them triangle? Anything else they give? Yes, sir, they gave it. These two are parallel. The two lines are parallel. If lines are parallel, what are the things which will come into play? Something which some of the things are there. So if any lines given is parallel, if they say any line is parallel, then we can have alternate angle and corresponding angle. These are the two things we can use them. So note, okay, something is there. When they say any two lines are parallel, we can use this one, alternate or corresponding. You know what is alternate, you know what is corresponding, right? So if you don't know, okay, just comment it down. I will forward the video where I have explained the detailed explanation is there regarding alternate angle and corresponding angle and how to identify them. Okay, so now come to the chapter. So these are the two triangles. So they told you parallel. So parallel means you can use alternate or corresponding angles. Okay, so alternate, you know what are alternating. So let me see what are the triangles first. So this is the triangle 1, this is the triangle 2. Okay, these two are alternate angle, parallel line. So and this is transversal. These two are parallel lines and this is transversal. So can I write this one equal to this one? Yes, sir. This because of alternate angle. So I can write this angle equal to this angle. Yes, sir, I can write. Okay, so we have written. Okay, now next if you say every time, okay, you'll have some common thing is there. But as the two triangles are totally opposite to each other, so obviously there is a chance to get a vertically opposite angle. Yes, sir, we are having a vertically opposite angle. So this one is equal to this one, we can say. Sir, we can say these two are equal. Okay, vertically opposite angle. So we have written. Okay, so to prove similar, we need only 2 points. So 2 points we have given them. Now can we say these two triangles are similar? Yes sir, we can say these two triangles are similar. So we have written these two triangles similar by which? Angle rule. Okay, we have proved. After that this is the next step. So this triangle is proved, this triangle is similar. So you'll write AO by OP in the next line, okay, by OC by CQ in the next line. After the cross multiply, get your answer. Done. Simple now. So here what we did, so in this question what we did, first and the foremost thing, first we have identified, okay, what we have to prove. We saw that we have what we have to prove. From there we saw that, okay, how to identify, okay, how to get the triangles. So we got the triangles. After that is easy. If you prove the triangles are congruent by some properties, okay, we'll get the triangles are similar. If they are similar, okay, we'll say that what they're saying to prove, we can easily prove that one. Okay, so this is also important point. When they say parallel, you'll use this one thing. Okay, so let's get into the second point, second question. Okay, understood this one very easy. So the proof, okay, the note thing. So the note what we have to write, these are very important. What where you have to use the alternate angle, everything you have to regarding the triangle. Okay, so go through the steps being given below nicely. See the diagram is there. Okay, what the diagram is saying. Okay, so clearly note down the diagram, everything you note down. Okay, being given to you step by step. Okay, so now let's get into the chapter next one. So there you go. There is the next question. The question is, in a given figure, the figure what they gave you, okay, where PQR, okay, PQR and QST are two right triangles. Means see 90 degrees there. Yes sir. So right triangles at R and T. Okay. So what you have to prove? The thing is to prove. So do they give you anywhere parallel? No sir, they have not given it. They told you only right triangles. Nothing else they give you, and you have to prove this one. We'll do it. What is the problem in that one? So this is a triangle. Okay. Where 90 degrees are there in the two places. Here at T and at R. There are two places where 90 degree exists. So what we have to prove? So QR into QS is equal to QP into QT. This thing we have to prove from given triangle what they gave us. So let us start the chapter. Okay, so this one what you have to do, again the same process, same drill. Okay, solution. So what you have to do, they gave you QR into QS is equal to QP into QT. Again the same thing, arrange them. Okay, now see QR and QS are lying in the same triangle. QR, okay, QS, yes sir, same triangle. How? QR is this triangle, okay, QS is this triangle. If I will take QR, the S will not come. If I will take QS, the R will not come. So how it will in the same triangle? So no sir, okay, no sir. Then sir, if I will take this one QR, so it can be QP or RP. QP is there, RP, okay, so these two are together, RP is not there. So I can write QR by QP. So what is left? Sir, what is left? Sir, left is QT and RS. So which one to write at the top? Now you see, if you write QS here and QT here, right? Okay. So first you see they are lying in the same triangle, QS and QT. QS and QT. Yes, sir, they are lying. Okay. Now arrangement we will see. Now we have arranged after multiplying QR into QT, QR, QT. No, wrong. Not coming. QP, QS. No, it's not coming. So arrangement is wrong. Okay. So what we will do? We'll rearrange them again. Let me see T here, S here. Now we'll see QR into QS. Yes. QP into QT. Yes, we are getting. So now the arrangement is okay. So from here we came to know the name of the triangle is QPR, the name of the triangle. So QPR, we have to take one triangle, and one more triangle is QST. Triangle. We understood these are two triangles we can take. Now again what we'll do? We'll take 2 points to prove them similar. After that we'll do the same thing. No sir, but they have not given any parallelness, only 90 degree they are saying. So first you see what are the triangles is there, anything they gave you, or any similarity is there. Okay, any common values are there. Okay, because see, the thing is that they told you 90. Means obviously in this triangle only 90 will exist. Okay, and one more, if common point will be there. One common will be there in the two cases. You will see QPR, QST. So what is the common letter in this one? So Q is there. So Q is common in both the cases. Okay, so you'll get 2 points. Let me see. So what are the two triangles which you have taken? QPR. So in that QPR, if you'll see, R is 90. Okay, and one more triangle was QST. So you see, T is 90 degree. So we got that value. So 1 point is done. So next point will be a common point, as I told you. So we have proved that two triangles are similar. So we have written the 2 points. We have proved it similar by using angle rule. Okay. After the same thing, you will copy this one. So this one by this one equal to this one by this one. Cross multiply, get the answer. Done. Nothing to do. After this, you will write this one as it is below. After this writing, you will write this one, and it's proved. So what we are trying to do, again the same thing, we have to identify the triangles. After that, what they gave you, you will write and you will get the answer. Simple. So the question is, they have given the diagram in the adjoining figure. E is a point on the side AB, AD produced of a parallelogram ABC. So they are saying ABCD is a parallelogram. Okay. Okay, and B is intersected CD at F. Okay. Show that one. What do you have to show? AB is similar to that one. So only they have told you ABCD is a parallelogram, nothing else. Okay. So parallelogram means what we can do? We know parallelogram, right? Okay. Maybe you will have some properties regarding a parallelogram. There is a small slide over the properties of parallelogram. Okay, you just go through that properties, okay, parallelogram, and write the points, key points. Okay, then I will continue with this one. Okay, there's a properties. So we saw the properties. Okay, so now some of the properties are there which we can use here, because there's told you ABCD is a parallelogram. So parallelogram means, so this will be parallel, right? Yes, right, sir. Okay, and this will be transversal. Yes, sir, for that one. Okay, and opposite angles are also equal. Okay, and diagonals also bisect. Okay, so many properties are there. So which properties we have to use? First you have to say which two triangles you have to consider that one. Okay, the triangle is this one and this one. Okay, this one and this, the two triangles. Okay, so if you'll see A, B, E. Okay, so now in this is the first triangle, this is the second triangle. Okay, so if you'll see, okay, so first property, okay, you will see the properties. One of the property of parallelogram, opposite angles are equal. Opposite angles are equal. If you'll see, so B equal to D, but B only half part is lying in the diagram. Okay, and D is not lying. Okay, in the triangle. What do we have to prove? No, we have triangle. We'll take the triangles. Or do one thing. I will extract the triangle. I will show you what I'm trying to say. These are the two triangles which I have extracted, which they are saying to prove. Okay, so now if you'll see, opposite angles are equal. Okay, so opposite to B, D is there. So if I'll say, if I'll see here, B is there. Okay, in this one, now it should have D. D is there? No, it's not there. So that one we cannot say. So can we say A equal to C? Now see, A is there. No, A is not there. So A is there, sir. A is there. Okay, A and C. C is there in this one. It should not be here. It should be in next one. Yes, sir. C is there. So we can use this one property. So we can say angle A equal to angle C. Why? Opposite angles of a parallelogram are equal. You saw the property. Okay. So one more property of that. Maybe you have written those property. If not, go back to the slide and write all the properties of the parallelogram, because this is given. So from the given only we will extract those values. Okay. The next property we'll see, as is a parallelogram. So these two lines are parallel. You can say, so BC is equal to, BC is, we can say BC is parallel to AD. We can say, yes sir, we can say. Okay, and we can also say that, okay, BC is parallel to AE. So how come so? Because ABCD is a parallelogram. Okay, ABCD is a parallelogram. They are saying, according to this, you say BCAD is okay, because BC is there, AD, all letters are lying in the triangle. But how come this one, sir? BC is there. Okay, BC is lying. A is there. E is not there, sir. So how can you say ABC in ABCD parallelogram, BC is parallel to E? How can you say? So the thing is that they are saying that, so AD is produced to D. AD is the line which has been produced to D. E, from D they have produced to E. So it's a produced line, extension line. So obviously it will be parallel to this one. It will be parallel to this one only. It's a line which is parallel, already told you, up to A to D is parallel to BC. But the line someone extended, and they have been produced this line up to E from the D. So we can say that AE is parallel to BC. We can say that one also. Okay. Yes, sir. Okay. So anywhere we can use that. If they are saying it has been produced, okay, it has been formed, it had been extended, so you can use this property. Okay. So write everything what I'm trying to say. Now from here, what we can say? From here we can say, sir, so these two are parallel. So this one equal to this one. Parallel, na? Parallel. Got the property. Okay, altered angle. Okay, so we can say that this one equal to this one. Sir, but we can say, okay, sir. So this one, this name of the triangle is AEB according to the parallel one. So AEB, okay, this is done. Okay, next one is EBC. So it's not that EBC is not lying, sir. So we cannot use that one. It's an extended one diagram. It's an extended diagram. Okay, you can do one thing. You write one thing. So what they told you from here, we are saying that BEA, BEA, okay, equal to, according to this is equal because extended one. So EBC, okay, angle EBC, okay. But the thing is that BEA, BEA, okay, this is lying. Okay, I'm having this one. EBC, sir, BC is there, E is not there. So this is not there. So how can I use the second point? Sir, how can we use, sir? If you'll see, if you I told you, so this is extended part. Okay, extended, but this is DE is the extended part. Okay, so can I say this angle equal to this angle? So we already told. But when I'm using the name of the triangle AEB, okay, equal to EBC, okay, can I use AEB equal to FBC? So how can you use? How can you use FBC? As I told you, it's the extended part. So this name EBC will be equal to that of FBC because this part is extended. The complete part is extended part. Okay, this one is a extended part. Okay, so because of that extended part, okay, so I'm not going to get the angle which is present in this one triangle. So now when I said that AEB equal to EBC, first point, they two are equal, I have proved. Now next I am saying that AEB equal to FBC. Why, sir? Because that FBC is the main triangle which we need. Okay, and this is produced, means these two are equal only. It's a produced part. Okay, so I can write in this one, next line, angle BEA equal to angle FBC. Now see FBC, yes, it is lying. So second point, you got the second point also. We have used the properties, okay, what I told you, and we have done the sum. So you have taken the 2 points as I told you. 2 points are there. Okay, first point and the second point, and we have showed that the two are similar by using the points which we have discussed. Okay, so this was an easy question, but the thing is that the produced, new thing which we have understood is the produced part, how to get the value from the produced part and how to use that. So whenever you have this type of produced part, so what to do and how to do this one, you understood. Okay, so this is the new thing. So we have successfully completed the second part also, where we have discussed some of the proof sums. Okay, and after completing this one, okay, just I'm trying to explain you how to just break the question, how to identify the triangles and what to do. After that, you know what you have to do. Okay, so I will come again with the next video tomorrow again. Okay, so complete this one, and if you like the video, it is helpful to you and informative, please hit like and comment and share. Thank you.